Well, do you remember the Marantz 2275? That I changed all the incandescent lamps to LEDs that the customer supplied, cleaned all the controls and switches. The customer said it sounded awesome, everything is working great. All of a sudden he noticed the right channel amplifier over here was running really hot, and then it blew the main fuse. And it didn't just blow it because it was a 5 amp fuse and it had 6 amps. It blew it violently. As you can see right there, you can see the silver particles on the inside where it arced. So let's go ahead and plug this thing into my PR57. I'll put it on the amp scale. We'll turn the power on, bring the voltage up slowly, and see what kind of amperage we get. Yeah, I know it's at a really weird angle, but I'm going to bring the voltage up very slowly. The power is on. I am on the 4 amp scale right here. 4 amps, 470 watts. That's at 120 volts. So let's bring the voltage up slowly and look at the current just rising, rising, rising. We'll stop it right at 3 amps and we'll check and see what the output voltage is. That's only about 12 volts going into the unit. So there's definitely a problem in here, a short of some type. All right, so here's a schematic on the unit. This is the fuse that blew. It's the primary fuse for the transformer. One connection goes completely back to here. The other one goes up somewhere over here to the power switch, and it actually connects this lead with this lead, which allows the 120 to flow through the fuse into the transformer and back to the neutral side. But since this is non-polarized, any side could be the hot, any side could be the neutral. Anyhow, what we're interested in is the orange, white, and orange. So the white wire comes from here. It's the second one down right now. Goes to here, and it finds cold ground, chassis ground. So what I want to do is go ahead and measure across the 2 big filter caps, 13,000 microfarad at 55 volts. We'll measure from the positive of this one to the negative of that side, and from the negative of this one to the positive of that side, and just see if we have shorts right there. We could just have a simple bad bridge rectifier, which I'm hoping for, or a shorted filter capacitor. That is the best case scenario. And this is the worst case scenario, that we may have a damaged output transistor. Remember I said that was unmolested? That might change. So anyhow, if you look at these pins coming in right here, this bottom pin connects directly to the emitter of this transistor at negative 47 volts. The next pin connects up here to the top of this P&P transistor at positive 47 volts. This third pin is actually the speaker output, and this pin right here is actually chassis ground. So worst case, we'll go ahead and unplug these plugs and find out if one of the amplifier modules right here has been damaged. Okay, so I have the ohm meter set up right here on low ohms, which is 600 ohms. So I'm going to go ahead and short the leads together, and we should see about 0.2 or 0.1 ohms, and we do exactly. So let's go ahead and test the windings of the transformer. Should see about half an ohm or less, and I see 0.6. That's perfectly fine. Now this is the output, the positive output and the negative output. Let's go ahead and see if there's a short between the two of them, and I see 0.6 ohms. All right, well, these are the 2 connectors for the amplifier modules. So the customer said it was the right channel, so I have it upside down. So this is actually the right channel. Let's go ahead and disconnect that connector from the main board. And we'll go ahead and check and see if we have a short again across the capacitor. And unfortunately, the short is gone. That's not what I wanted to see. Well, let's go ahead and pull the amplifier module out of the unit and see what kind of carnage we actually have. All right, well, there is the amplifier module out of this unit. The 2, well, previously unmolested output transistors. I think that's probably going to change right now. And we'll go ahead and check the drivers and the pre-drivers. We'll test the couple of electrolytics on this board, although I've rarely ever had electrolytic problems on an amplifier board. Had them in the preamp and the power supply, but rarely on the amplifier board. So let's get started. Okay, so I've just made a note where the 2 transistor goes, S40442, and where the 3 transistor goes, S40443. So we're going to go ahead and just zip the 4 screws out right now. Now we should be able just to grab the transistors. They are in sockets. Just a gentle tug, and they should come completely out. Okay, I have the meter in the 600 ohm range. So we'll test from the collector, which is the case of the transistor, over to the emitter, and we do not want to see a short, and we see a short. Same thing on this one, and it is a dead short. Anytime you have a problem with the output transistors, always test the drivers and associated components. So the problem that we're having is these two output transistors are shorted right here. So I want to check these driver transistors right here, these 100 ohm resistors, to make sure that they have not been compromised. Check the 0.2 ohm emitter resistors right here. This is the bias tracking transistor. I want to make sure that this little diode right here has not been damaged, just in case. Okay, so luckily I can get to a lot of the parts on this unit without even having to take it off the heatsink. I can get to R734 and R735, which are the resistors connected to the driver transistor. They're supposed to be 100 ohms. So let's put this on the 600 ohm range so it doesn't have to take time to auto range. And I see 99.4, perfectly fine there. 98.2, I'm very good with that. I'll go ahead and put this onto diode range, and we'll check from base to collector on the driver transistor, 580. Base to emitter, 583, I'm good with that. Collector emitter, 1.23, and emitter collector the opposite direction, 1.05, I'm fine with that. So I'm going to reverse the leads. We'll go from the base to the collector on the other driver, 576, that's good. 583, that's good, and we'll check collector emitter, 1235, reverse the leads, and we'll check collector emitter one more time, and we get 1150. I'm pretty happy with the driver state. Okay, so here is the bias regulation transistor underneath this heatsink. I'm on the diode range, 553, 444, let's reverse the leads, 495, and 425. I'm not really happy with those readings, so we're going to have to pull the circuit board off the heatsink and do some individual tests, maybe unsolder the leads and see what we get from there. Okay, here's the same view with the board flipped over. As you can see, I've unsoldered the bias regulator transistor right here. So I'm just going to measure the pads now. And we see 869, 444. I remember 444 before. And 515. So we do have resistance between the pads. So let's go ahead and check the leads of the transistors without the pads. 622, 626. Collector emitter, nothing that way. Reverse the leads. So now I should see no diode junctions. Nothing. Nothing, and nothing. The bias transistor is good. So the next thing I want to do is check these capacitors with an ohm meter first, just to make sure they're not shorted or leaky in any way. So I'm in the ohm position with the auto range on, and that's good. Reverse the leads. I should see something. So it's discharging. And now it auto ranged, and we're totally open, perfectly fine. Now this one's discharging, and there must be a little resistance. It keeps auto-ranging, but it keeps going up to the infinite range, so I'm perfectly happy with that. And I see 6.5K that way, basically. Perfectly happy. Let's go ahead and check the ESR of those two caps now. Okay, with the blue ESR meter, let's go ahead and check the two capacitors. So I see 0.3 ohms and 1.6 ohms. I'm totally happy with that. Let's look at the values and see what they actually are. This one is a 47 at 16. And this little guy right here is a 10 at 16. I'm perfectly happy with both of those. I don't think they're causing any kind of problems whatsoever. So with the driver transistor still unsoldered, let's go ahead and check this diode and make sure that we don't have any problems with the bias tracking diode. 874 that way, and 494 that way. Let's go ahead and unsolder that diode just to make sure that there's not another component across it causing problems. Okay, so I went ahead and unsoldered both leads of the bias tracking diode that lives under this heatsink right here. So let's go ahead and measure the resistance on it now, since it is loose in here, and we see nothing that way. I'll reverse the leads. We should see a junction in this direction, and I see 513. I'm perfectly happy with that. So as far as I can tell, everything is good. I tested the emitter resistors. They're both good, 0.22 ohms. R734 and R736, the 100 ohm driver input resistors, are both good. The driver transistors are good. The bias regulating transistor is good. The bias regulating diode is good. So I think I'm just going to go ahead and get a couple of output transistors, and hopefully that takes care of the problem. And I'll have to instruct the customer on how to test his speakers completely, how to test the mid-range and the tweeter if it's a three-way system, or just the tweeter if it's a two-way system. And I'll probably make a video on that upcoming to let you know how to test your speakers without really anything other than a voltmeter and hear the quality and make a determination, are they working or not. So I did go ahead and search a bunch of forums, and I found a suitable replacement set of transistors for this power amplifier from On Semiconductor, the MJ21195G and 21196G PNP and NPN transistors. So I went ahead and ordered some of these transistors right here, and we'll go ahead and throw them in there. We'll double check the idling current, and I will check the DC offset, which I did check off camera. I did have a commenter mention that I should have checked the idle current and offset, which I certainly will be doing upon power up this time. And I do believe that these transistors are way, way higher power ratings than the original transistors would have been. Total device dissipation, 250 watts on these guys with a collector emitter voltage of 250 volts. This thing's only running, I think, about 50 volts collector voltage. So I think these are going to work absolutely perfectly in this unit. Bring it back to life, and with a much higher power rating, I'm sure, than these original transistors were rated at back in 1976. I don't ever see having a failure in this circuit again. So let's go ahead and stab these in, power the unit up slowly, and see what we get. All right, it's all buttoned up, ready to go. I am going to go ahead and hit these pots with deoxit just to make sure that they're going to be okay. Then we'll put this unit back in, fire it up. Like I said, bring the voltage up slowly while checking for high current draw and DC offset at the same time. We'll put them more or less where they came from. Well, let's do a real quick ohm check now from the positive to the negative. And I see charging, so we'll check from positive to ground. Good, and negative to ground. So I see no more shorts. Well, let's go ahead and power it up and see what happens. All right, so here are the audio adjustments. Number one, 35 volt B plus voltage adjustment power supply. Connect a DC voltmeter between the pins of J804, J805. Adjust the trimming resistor R806 for 35 volts DC. And I do have it adjusted for exactly 35 volts DC. Okay, so next we'll do the DC offset adjustment. Connect a DC voltmeter with a 0.5 or 1 volt range. I'm in the millivolt range on the right hand meter across the speaker terminals. Adjust trimming resistor R741 for 0 DC output on the meter. Well, that's certainly going the wrong way. That's pretty doggone close. 0.5 millivolts, half of a millivolt. Next, we'll go ahead and do the idle current adjustment. They tell you to connect a vacuum tube voltmeter, but I don't have a vacuum tube voltmeter, unfortunately. Next, rotate the trimming resistor R742 fully counterclockwise, and then rotate it clockwise until the vacuum tube voltmeter reads 10 millivolts, which is 25 milliamps across the emitter resistors. And it was up at 25 millivolts. Which I don't think would cause that much of a problem, but we'll get it as close to 10 as we can. 10.0, 10.1, close enough in my book. So now it tells you to recheck the DC offset. So now it's at 1.1 millivolts. So let's go ahead and try to dial it down close as I can get it to 0. I may not be able to get it any closer. Wow, it's really touchy. Well, we're back down at 0.5 millivolts DC offset and exactly 10 millivolts DC bias. So next, just as a safety precaution, I'm going to go ahead and change the other transistors in the other channel for this customer. Then I'm going to hook it up to a dummy load and crank this thing up with some power, let it warm up, and then I'll recheck the bias and the offset. Okay, so just like last time, we'll go ahead and adjust the DC offset, which is this one right here. We'll try to get it down to as close to 0 volts as we can. And it says to take the bias all the way to minimum and then bring it up to 10 millivolts. That's pretty doggone close. 10.3 and 0.2 kind of drifting around millivolts DC. Back that off just a hair. Well, let's get some speakers connected to it. Make sure it plays sound. Okay, so I have the amplifier connected to a dummy load, 8 ohm dummy load, and I have it connected to my audio power meters right here, and I have it set to the 10 watt scale because I'm just listening to music power. So I've got it set to just about the point of clipping. And I'll let it run for about 5 or 10 minutes like this. We'll check the temperature of both heat sinks. Make sure that one's not hotter than the other one is. So let me show you the current draw as well. So there's the current draw at a low audio level, and I'm on the 1.5 amp scale, so we're drawing about half an amp right now. And once the bass hits, we're up to an average of about 1.25 amps, or about 150 watts input to this unit right now. That's RMS music power, not constant tone peak power. We'll let it run for 5 or 10 minutes, and then we'll go ahead and check the temperature of the heatsink and make sure they're both within tolerance. So as it sits right now with the warm heatsink, we're at 8.9 millivolts DC bias on the right channel, and we're at about 5 millivolts DC bias on the left channel, which tells me the temperature bias tracking is working absolutely perfectly. All right, so this is the right channel. It's picking up some kind of reflection as the hot spot, but it's showing a temperature on the heatsink of 120.7 degrees. So let's go look at the left channel right now. This is the left channel. As you can see, it's a few degrees warmer than the right channel is. So I've had it playing for about 10 minutes at a pretty high volume level. And we're showing about 125 degrees peak temperature. So we got a couple components down here at 171 degrees. Those are a couple of power resistors down in there. but I'm mainly concerned with the temperature of the heat sink itself, which is in the 120 degree range. And over here on the right channel, we're at a temperature of about 116 degrees, so definitely the right channel is much cooler than the left channel is. Overall, there's a really hot spot over here on the power supply, 176 degrees. That's that big power resistor right there, but there's nothing I can do about that. Overall, the thing's running pretty doggone good. I mean, the right channel definitely has a lot cooler temperature than the left channel does. So there's just one more thing the customer wanted me to do on this unit, and that was to see if I could adjust the FM tuning meter centering. I think I can do it. So even with nothing applied, and I'm in the auxiliary input, so the FM tuning is not taking place, it's still offset just a little bit. So I'm going to have to try to pull this plastic cover off of the FM tuning signal strength meters, which means I will have to unstring the dial cord once again to get to it. So let me see if I can take care of that for this customer. So I've got the tuning meter out of the unit, and it looks pretty good right now. But watch this. When I hold it up vertically like it mounts, look at the centering on that. It's way off. And I think I can go ahead and adjust it inside right there. I just got to pull the faceplate off. But they must have adjusted it laying down like this, because like that, it's absolutely perfect. So there's a close-up view of the meter movement itself. You can see the needle hanging down right here. It's pretty doggone close. Right now, like I said, if I lay this thing flat, look at that, it's almost perfect. But watch what happens. I realize the focus is going to be off on this if I stand it up, because this thing is used in a vertical position. Look how far off it is. So what I need to do, this is actually thread lock. The green stuff you see right here, I need to soften the thread lock. And what's better to soften the thread lock than a little dab of acetone? So I'm just going to try to dab some acetone on here from the tip of a screwdriver. I don't want to get too much on here. So I'll let that soak in for just a moment. Okay, so if everything goes well and the acetone has softened the thread lock, I can just move the slider a little bit, and it's going to see how it's moving the actual spring right there. So now if I stand it up, might have went a hair too far. Let's bring it back just a little bit. Oh man, look at that. Now if I lay it flat though, it's going to be over here on the left side, which I don't mind, because this meter is going to be used in the vertical position, just like that. So there's the meter standing upright right there. Looks absolutely perfect, and we still have good meter movement. As I jiggle the meter, you can see the needle is moving. But once again, if I lay it down flat, there's perfectly flat. Look where it lands. I believe this has probably been a defect in this unit since the day it was manufactured. But got it adjusted. Everything looks great. Just got to put it back together now. All right, there it is, all put back together. That is in the phono mode right here. So the tuning meter should be right in the center, and it actually is. Now let's put it on an FM station. It tunes right through the center of it absolutely perfectly. Back to auxiliary. Dead center. Absolutely perfect. Well, there it is. Back up and running at a fairly substantial volume level. So I really don't think that small DC offset and small bias being from 25 to 10 really made much of a difference. But anyhow, customers got all brand new output transistors on both channels. Much higher quality transistors than originally came in this unit. I am convinced of that. These are rated at, what I say, 16 amps total output current. There's no way this thing could ever deliver that much current. Anyhow, it's up and running. Just got to put it back together and get it back to my customer. Well, I certainly hope you enjoyed part 2 of the repair on the Marantz 2275. Go ahead and leave me a question, a comment, a concern down below, good or bad. I try to respond to the comments when I have time. While you're down there, hit that subscribe button and like this video. It really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me norcal715videos@gmail.com. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everybody, thank you for making it to the end of this video. I really do appreciate it. By the way, I did cut a very good break in the labor for adjusting the meter while I was already in here doing the other repairs on the amplifiers. Everybody have a great day. Thank you so much for watching. Bye-bye. Okay, a little bonus footage. Let's go ahead and test the transistors with an ohm meter, not in the diode range, just to see if they are leaky or not. So first, let's go ahead and test the S40442. So we'll test between the base and the emitter. And I see 10.9 megohms. That could be the diode junction, but if I reverse the leads, we should see infinite, and I see 1.07. So that is probably the diode junction. There it is. That is the diode junction. So now let's go ahead and reverse the leads, and we'll go ahead and check emitter to collector, and I see an open. That's perfectly fine. Check out the other direction, and I see 13 million ohms. That is leaky because I should not have a diode junction, and I do not. No diode junction. So I should see a diode junction in one direction, which I do. A little low, 501. But I should not see any kind of leakage in this direction and no junction. So that transistor is leaky. Definitely bad. Let's test the other transistor now. So this way I should see a junction. And I do. 484, a little bit low, but I see 2.1 million ohms that way, which could be acceptable because I'm not on the diode range. That way's perfectly fine. Let's check collector emitter, perfectly fine. And reverse the leads, collector emitter, perfectly fine. And we'll go ahead and test them both with the MK168. See what they read. NPN, gain of 48, forward voltage 514, collector base emitter. Interesting, that one shows a diode in one direction with a beta gain of only 30. Wow. So that is the defective transistor. Let's go ahead and get the ohm meter out and verify that that one is the bad one. So remember, this is from the other channel, the good channel. So if I read emitter to base, I see 1 meg, but I think that's the forward voltage. Yes, it is. Let's reverse the leads. And I see resistance. The MK168 picked up on that. That is a defective transistor. So chances are this other channel would have died sooner or later as well. Everybody, thank you for watching the bonus footage. I really appreciate it. Everyone have a great day. Bye-bye.